So students, in this lecture, in this video, we'll be solving numerical number 2. This type of numerical can also come in examination, okay? So what the numerical is? The numerical is a rectangular beam of size 230 mm into 350 mm, which is effective, right? Effective depth, right, is given, is subjected to a shear force of 50 kilonewton. Important, subject to shear force of 50 kilonewton. The permissible shear stress is 0.25 Newton per mm square. The design shear force is in kilonewton is. So very simple question. I told you that if you want to determine the design shear force VD, it is actually equal to the factored shear force, the total shear force acting minus tau C into BD. What is tau C? The critical shear stress or the permissible shear stress of concrete, right? If it is given to you in question, well and good. If it is not given to you, then you have table 19 from the IS code, right? Page number 79, I told you, right? So from there you can get the answer. But in this question, the permissible shear stress is given to you, right? So it means that for how much force, for how much shear force, you need to design the section. So let us see how much is the force. So tau C is into BD will be automatically taken care by the concrete itself, right? So how much the total force is 50. So design force will be equal to 50 minus tau C. Tau C is how much? 0.25. 0.25, but this is Newton per mm square. If you want to convert Newton into kilonewton, what you have to do? You have to divide it with 1000. So divided by 1000, it will be equal to kilonewton per mm square into B into D. How much is B? That is 230. And how much is D? That is 350. So I hope that you have understood this concept, right? Now, it will be equal to, let me calculate it, it will be equal to 0.25 into 230 into 350 divided by 1000 and minus 50 into minus 1, 29.875. 29.875 kilonewton is the design shear force. Is there an option? 29.87. This is the correct option. So B is the correct answer. So it was a very straightforward question, but this concept was taken into this numerical. This is important because when you are designing very big beams, so this concept has to be taken into consideration. So I hope that you have understood the type number 2, the numerical number 2 on shear, right? So let's meet at the next videos and next lectures and let us understand a few more concepts. Thank you.